Hey, this is lesson 2.4. Today we're going to find empirical and molecular formulas. Now, empirical formula, remember that was the reduced formula. And so it's reduced to its simplest form. Molecular formula is for the covalent bonds, and it does not reduce. And so this is a way that we figure out what the formulas are from the percent composition. So this is what we figure out from the percent compositions that we did yesterday. All right, let's see if we can get this thing started. A little trickier than normal. We'll just slide this over here and see what happens. Now, you notice that I made a map. Of course I made a map. Let's get this, there we go. There we go. Of course I made a map so we can see where we're going to go. So in this case, we're going to go from percent to grams to moles to a mole ratio and then make subscripts. Now, I know we know what percent is. How do we go from percent to grams? Let's start off, and we're going to have to do this in 3 different things, so hopefully I have enough room here. I can always take and move my map up a little bit. There we go. It's going to be a similar map for every single one, so let's put it out of the way. Okay, so we have 68%. Oops, let's change that. We have 68.4% chromium, and we have 31.6% oxygen, and we're going to try to find the empirical formula for these things. So, first step, percent to grams. Hey, you know what I like to do? Just make an assumption. Let's just pretend we have 100 grams. If we have 100 grams, then we can do a really quick, easy conversion. Because if we say we have 100 grams, and we have 68.4% of 100 grams, well, we're just really saying, uh-oh, let's change the size of that eraser. We're just really saying that we have 64 or 68.4 grams of chromium, right? We're assuming we have 100, and that's the easiest way to do that. So if they give you percent, just say, hey, I'm going to assume we have 100, and you can just change that right to grams. All right, first trick of the day. All right, now we're going from grams to moles. So when we go grams to moles, we have to cross out the grams of CR, and we'll change that to moles of CR. If you have grams over moles or moles over grams, the moles is 1, boop, and the grams comes from the periodic table. And I'm seeing here, my table's right beside me, and I see that the grams of CR, 51.99. Of course, we're going to round that to 52. So we're to moles. I have too big of a line here. We'll just go with it. Okay, so we have, let me partial, got a little carried away. Whoop. Okay, and we'll put an equal sign here. All right, so we're going to take the old trusty, heck, let's take a calculator today. So we have 68.4. Let me clear this all up. 68.4 divided by 52. And boop, 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 boop. Where's the thing? I can't tell. That didn't work. Let's don't do that again. And I got 1.315. I don't know. I just went to 3 decimal places. That's fine. You don't have to do that. Okay, so we have moles. Now we're going to find the moles of oxygen. So same plane. We assumed that we had grams. Percent was grams. And now it's 16 grams of O per 1 mole of O. Okay. 31.6 divided by 16 equals 1.975. Okay, now those are the moles. Now we're going to find a ratio. So a ratio just means that it's comparing the numbers. So if you had 4 boys and you had 2 girls. The ratio would be 4 divided by 2, which would be 2 to 1, right? So you're going to take the smaller number, the smallest amount, and divide both of them by that smaller amount. So we're going to take and divide both of these numbers by the smaller number of moles. And that will reduce it down to a more usable, a friendlier whole number version. Let's get a calculator and see if that works out. So I have already in my calculator, well, I know the first one, 1. The second one, and the next one equals 1.5. I wish I wouldn't have started with this one, but we can see what we have going on here. Now, it's reduced too low because it's a 1 to 1.5 ratio, right? We want to be the simplest whole numbers. So what we're going to do is say, hey, we have 1.5. How do we get that to the whole number? Let's times it by 2. And if we times 1 by 2, we have to times them both by 2. And so we end up with 2 CRs and 3 O's. Formula, what did I say? 2 CRs and 3 O's. And that is your empirical or simplest formula for, well, that would be chromium 3 oxide, right? Chromium 3 oxide. You don't have to name it, but I thought it would be fun. Cool? All right, slide it up. Similar type thing. Okay, the same thing's going to happen. I'll save this for you. There's a key for this page, right? You can look at it, try to figure it out, and that'll be easier. Let's go to something that's going to be molecular formula. Right here, number 5. Number 5. Same setup. The only difference is going to be the end, okay? And so hold on tight. I got to get through this other part. So we have 5.9265. They put a bunch of decimals on these so they come out nice. So that's why we're doing that. And remember, percents can be assumed into grams of H. We have 94.0735, oh my goodness, grams of O. I wonder if this is going to be water. What do you think? Might be. It might not be. Okay, and determine the empirical and the molecular formula for this thing. All right, so our first step is, if you remember from that map I have, we're going from grams to moles. So grams of H to moles of H. 1 mole, 1 gram. Easy peasy on that one. We have grams on the bottom of O. That's 16 grams per 1 mole, right? Not too bad. So this number is the same, 5.9265. And this one needs a little calculation. 94.0735 divided by 16 equals, I'm getting 5.9. Oh my gosh. Are you seeing this? 5.9, right? So let's do this. The ratio is going to be, all right, I'm taking the change off that thing. Let's make it simple. That's a 1 to 1. It's a 1 to 1. H1O1. That's the simple formula. That's the empirical. That is not the molecular formula, though. All right? So how do we figure out what that is? We look up here. Yep. Let me look where we're looking. Look up here. We're going to look right here. It says that it has a molar mass of 34.01468. We'll just say 34, right? Okay. So how much does the mass of just this one thing weigh? Well, we have 1 plus a 17, 1 plus a 16 equals 17. I got my math a little ahead of myself. So 17, right? And we want to know how many times 17 goes into 34. So this is for the molar or the molecular formula. First, find the mass of the empirical. Okay. Then take the molar mass, they'll give it to you, divided by the empirical formula mass. So that's going to be 34 divided by 17, which equals 2. It should be a nice round number, okay? And what that means is we have 2 of each thing. That since this thing is half as big as it should be. So instead of being H1O1, the molecular formula has to be twice as big as that. So it's going to be H2O2. Which reminds me of a really bad joke. The guy goes into a restaurant. Well, 2 guys go into a restaurant. The one guy says, "I'll take a H2O, please." And the waitress says, "What will you have?" And he says, "I'll take an H2O too." And he drank it and he died. This is hydrogen peroxide. I doubt if it would kill you if you drank it, but if it was strong enough, it would. And so H2O2, if you don't get that joke, ask your parents, they'll explain it. All right. Hey, that's it for both of those. So that's done for this lesson. I hope you have good luck with this. We are doing, oopsie, there's a key. See the key? I got a little lag up there. So we have a key there, and it looks pretty nice. Then it has another page that's blank. You don't have to do that. I just couldn't separate the PDF. If you want to do it, you can, right? But there is only a key for the first 5. I'll probably throw up another key in a day or so. Well, depends on, maybe even today. And then you'll have that to look at too. I'll do a key with just answers though. And I want to see work. We need to see, oops, doggone it. Somebody emailed me and I touched it just at the same time. Adrian. Okay, how do I get back to my thing? There we go. All right, so we need to see the work. Show your work. That's what I'm grading. And make sure you understand what you're doing because that is the goal. We want to make sure that we understand this chemistry as best we can. And I will see you soon.